So when we were doing this nested iterations, right? Supposing we were trying to find all pairs of students who have the same marks in some subject, for example.
Say maths.
Say maths.
Okay.
So we had to be careful that we didn't count the same pair twice. So, if say Shashank has the same marks as somebody else, when we are looking, so we would of course compare one card with another card, but we don't want to do it twice.
Firstly, you have to make sure that you are examining all pairs.
Yeah, so we have to go through every card and compare it with every other card. But then sometimes when we come to every other card, you have already compared
this card.
Yeah, so you don't want to do it two ways and record that pair twice.
Yeah.
So then what we did was after we saw a card, we moved it aside somehow. So we had these two piles of cards, those we had seen and those we had not seen, and then we had to be careful to make sure that the next card is compared only against the unseen card. So we have to keep doing this
very
careful movement of the two cards. So it would be nice if we could avoid that, if we could somehow record the fact that this card has been seen, so that even if we see it again, it does not matter, we see it has been seen once and then we will not compare it a second time, but we do not have to be careful about keeping these two separate, physically separate things.
So, I mean, in principle we are keeping it in a separate pile, but you are saying I do not want to keep it in a separate pile.
Yeah.
Some table 1, 2, 3 and all we had.
Correct. So we move it from we move it from table 1 to table 3, then move it back to table 2
and all that.
Yeah.
So you are saying do not do that, just mark it.
Yeah. So when I see the first card, supposing I see this card, I will say that card number 2 has been seen. So then I will compare it with everything. Now when I start looking at 10, when I compare 10 back with 2, I will say 2 is already been seen, so I will just ignore it and skip to the next one. Right? So I am just saying for every card, compare with every other card. If the second card, first of all, the first card must be not seen, and the second card must also be not seen, and only then we will actually check it.
Okay.
So how do we do that?
You can write the seen, not seen.
Yeah, but if you do it now, but also that will work now. But then the next time I will have to have a second mark.
Next person was doing it.
Yeah, so each time we do an iteration, we will end up marking it, and the whole thing will get messed up. No? So
we need to have something else which we write on and then stick it, sticker or something.
Yeah, so we need to record this basically, right? So we don't want to record it on the card because that damages the card for future use.
Correct.
So somewhere we need to collect. We need to collect this information somehow.
But card wise.
Yeah, but that collection is by card, and we don't want to go back and check. So we could of course keep a list of these cards we have seen, but then every time we have to go through that whole list to find out whether the card has been seen or not, and that's very inefficient, right? We don't want to go back and.
No, you should be able to say this is a card number, right? So I should be able to say is card number 2, which is what I am holding right now, has it been seen or not? Okay. And I should be able to instantaneously get the answer.
Yeah, so that we should have some way of having a collection of values where I can ask by the value.
So it's not a list.
It's not a list.
Because list I have to search.
Yeah. So list is by just a sequence.
I could have just kept seen, unseen, unseen, seen, like that.
Yeah.
But then I have to go down the list to find, suppose this 2 is okay because the second item is 21.
Yeah.
To go down 21 elements to see.
Correct.
No?
Correct. So that by position or whatever, it's very clumsy. So so we need this new kind of a collection where we can index it by the value we are searching. Is this value there or not? Something like that, or what is something. So just now we just need that. Is this value seen or not? Right. So then we will just have to be able to quickly say card number 22 seen, yes or no. Card number 12.
So maybe there is something like that. I don't know. Is there a thing like this that people in programming languages use?
So I think something called a dictionary is what I think this is, where so a dictionary now is a collection where you have values of course, but for each value there is a way to get to that value. So it's like a key.
Oh, okay.
Right. So it's not a position. It's not the first item, but the second item. It's a item labeled 2. It's like a label. Item label 21, and in this case we just need the label. The value is just whether it is seen or not. So the value is always in this case just true or false.
So initially I guess for us right now initially
yeah, everything
dictionary
is empty.
empty,
Right? Empty. No
which means
labels
not
are
seen,
no,
no label.
Yeah, no labels or no keys.
So you start with an empty
Dictionary.
Then what do you do? I mean, okay, let's try.
So let's see. So
Yeah.
we have this dictionary. So we have this dictionary called scene. Right? So initially it's empty.
Initially empty.
And now we want to check whether anybody has the same maths marks as.
So you can go anywhere, right?
Yeah.
So let's say we start with this. So Shashank, so it's 2.
So now the first thing we'll do is we will record
2 as seen.
2 as seen. So we'll just put 2 there.
So 2 is, so what does it mean? It means against 2.
Yeah. So I will say that.
It's not a list. So against 2 we have. we
Yeah.
have
So
put
actually
seen.
it's more like so you have 2 parts to it, right? So you have the key or the index or whatever, right?
Okay.
And this is the value associated with the index. So we are just saying that for the card
Has
number
it been
2,
seen, you're saying it's true.
yeah. So we are not keeping the false right now. So everything will have value true. So we are only looking at this index part. So now 2 is true.
2 is true. So I put. I mean, right now I'm putting it aside.
Yeah. And now we will check for each of these. So we will look at 10 and ask whether 10 has been seen. And ideally,
Right now there's nothing. There's
yeah,
nothing.
it should instantaneously tell us whether, I mean, without any long wait, we should be able to check whether 10 has been seen or not. So 10 has not been seen, so we will compare these two.
Okay. So 10 is not there.
Not there.
In the dictionary.
Yeah.
Which means 10 is not seen.
10 is not seen.
Okay. Then, so what do we do
So
now?
now, yeah,
so we can
this
compare
is,
that.
we can compare.
So
So
maths-
separately there,
So
somewhere
we are
else.
comparing the match marks. In this
Yeah.
case, we are actually comparing.
Yeah. So we are
64.
doing, yeah. So separately somewhere else we want to keep these maths pair.
Yeah, maths pairs. Yeah. Okay.
Right.
So
So,
right
we,
now, so
we are
this
now
is-
seeing if any pair includes 2.
So this is not a pair.
It's not
so
a
I put
pair.
it aside.
Yeah, I can put it
Put it
aside.
Then I start with 52.
Yeah, not a pair. No, no.
Now what do I do?
No,
with
no.
it?
We have to compare it back to we are doing a nested iteration. So we are starting with 2, comparing with 10, starting with 2. So we are going through all the cards once to check if any of them has the same marks as.
We'll compare with all. Actually,
Yeah.
actually we should go through everyone.
Go to every one of them. But all of them right now. Are,
After I mark this in, I can put it back in the pile.
yeah,
That's what I'm saying.
yeah, yeah. So we will just keep. We don't have to separate the 2 in a
okay.
separate pile.
We don't have a table 3. You don't need that. Okay.
yeah.
So you have 52. You can check again with.
Yeah. So we are looking for number 57. I think. I think. Yeah.
We can do 57 and 64. We compare with.
Yeah. Now 57 and 52 now we compare with, because 57 is the one we are we are looking at this card, right?
Oh, I see. Okay, okay, okay. No, no, I'm sorry. So what did we do now? We do 57.
Yeah.
And then?
We are checking whether any of the others have 57 or not.
Okay. So I keep this aside.
Yes.
And then 64 I have done. 52. I still have 3. Oh, but there's only one card.
Yeah.
Okay. Then I see 71. This is also unseen.
And see.
So actually I will compare it. In the first case at
First
least
we'll compare with everybody.
Okay. So I'll go like this. Let's do that.
Yeah.
Let's do it all then. 57. 57 is
So far no duplicates.
unlikely that it will be there. Unlikely. I don't know. We'll see. 56. Okay. Close. 89. 74. It looks. Doesn't look like there are any duplicates in this by the way. 70. We found a pair actually. There is a pair. 68. 87. 63. 62. 44. 87. All right.
So now we didn't find any pair for that, but now normally we would have kept this aside. Now we are saying don't keep it aside. You can just put it back into this pile. It doesn't really matter.
Oh, like that? Because we have marked it as
Yeah.
seen. Is it?
Yeah. So I'm moving it. Yeah.
Oh, that is 2, right? The 2 card 2.
Card number 2.
Card. It was a 2 actually. Okay. 57 was 2. Huh?
Yeah.
Okay. All right.
So now I look at 16.
Now what, I have to take 16 and enter it
Yeah.
into the.
Yeah.
Huh?
So now 16 is not seen. So I have to compare with 16 with everything. So I'll first record that 16 has been seen.
Oh, I see.
So that I won't do it a second time. And now I will go through everything again.
Okay. Let's see. Let's do it. Okay. So 16 is set aside, and then we look at this one.
To see if there's any more 87 mark.
But when I come to that card which is 2,
Then I will, so for every card I have to
keep it.
technically check.
Check.
If 9 is seen, then don't compare. If 9 is not. So 4 is not seen and it is equal. So now I have
0 is
one
not
pair,
seen.
16
I see. Okay, I get it. Yeah.
and 4.
16 and 4 are equal. Okay. Yeah.
Yeah.
So 0 is not seen. 29 is not seen. 18 is not seen. 15 is not seen. 20 is not seen. 28 is not seen. 14 is not seen. 19 not seen. Like that. You have to keep going.
Keep going. The one more which is 87 and
25
25 is not seen. So, I have one more pair 16 and
25,
25.
23, 13, 3, 11, 6, 7, 21, 27. What happened to 2?
It's right at the bottom, I think.
Okay, 71, 52, 64. Okay, it's right.
And now, because this is 2 is seen, we will not
we'll
compare
skip it.
skipped in. Yeah, we will skip it.
Skip it, and then we can now put this
Anywhere.
card also back.
Yeah, anywhere.
Because 60 mark anywhere I can put it.
Yeah.
And I do the same thing again.
Yeah. So, now for instance, the top card is 2. Now, we should not maybe shuffle it, but the top card is 2. We have already seen 2, so we don't do that.
Anything.
So, we look at 10. So, 10 is new. So, I will add 10 here and so on. So, this is not the best way to do it, because we are kind of mixing things up. But in general, we are saying that if we have an outer iteration which goes through all the cards, the inner iteration can also go through all the cards. And whenever we look at the outer and the inner pair, we want to make sure that the inner one is not seen. So each time we do an outer one, we mark it as seen.
Okay.
And so that
will allows us to keep only 2 piles.
And this scene is part of this iteration. So we go to some other problem, this can be thrown away, we start again.
I see.
Right. So we don't have to permanently mark the card or do something like that, and that's one advantage of using this.
So this business of writing scene. So actually, when we have this dictionary called scene, we added an additional property for the card.
Yes.
Right. Relative to the algorithm, of course.
Correct.
It's a kind of a state.
So this is a kind of a new property.
It's a new property we have created.
Yeah. So we could have written it on the card, but then that will be a permanent addition to the card, which we don't want
to do that. But we have many things like that. I mean, we wanted to give grades to students.
Yeah. For example, so we have assigned grades, but the grades are not recorded here. But during the
or we found out whether a student is above average. So you may want to write this student is above average, because each time when you look at a student, you want to know, is this person above average, then you don't want to compute.
Yeah. So you could keep this kind of.
But I don't want to write on the card.
Yeah. So this dictionary we can keep and reuse later in the computation.
So you can have many dictionaries. You can have one dictionary to check for storing the grade of the student.
Yes.
In maths, another one for physics, another one for chemistry, another one overall.
Yes.
And then I could if I have Srinidhi and I want to check whether the person, what grade the person is, I can go look at the appropriate dictionary and get the answer, right? Without having to compute it, because I have stored it. All right. Okay. This is interesting. So, I mean, so dictionary is a way to take cards and add more properties to each card, right? That's what you are saying.
So, for instance, if you are keeping grades, then for example, the Srinidhi's grade, so it is card number 12. So, you might say that the grade associated with 12 is maybe B, I don't know.
Okay.
Right. So, later on if you ask me what is the grade for 12, right. So,
I can just look up this
dictionary. I can look up the dictionary. So, it will have a lot of such, so 23 might have got a grade C and 14 might have got a grade A and so on.
But what you are saying also is that in the dictionary, the way it is implemented, you don't have to actually search this thing sequentially to find it.
Yeah.
It will somehow magically.
Yes. So, I just give it, and it will, if there is a left hand side, it will give me the right hand side.
Immediately.
It does not matter whether it's in the beginning, it was added early, added late.
We don't know how that is implemented, but there is some way of doing it.
So, it's
okay. All right. I mean, so the key, in this case of course, key is number. What are the things? I mean, key can be anything or?
Yeah. So, if we want, so here we use a number because this card ID uniquely identifies, but we could also remember by name. We could say grade of Srinidhi, for example.
So, you can have a key which is Srinidhi.
Yeah. Yes, we could have a name grade thing. So, another grade by name. Right? And so, here we could say that instead of saying card number 12, we could say Srinidhi got a B and Kavya got a something else, maybe also got a B and so on.
I see.
But now, of course, we know that here the numbers are unique. Right? There is only one number.
This is another way to find out whether there is only one Srinidhi or not.
Yeah. So, we might come down and then somewhere later on you might find another student called Srinidhi.
Then it will clash.
Right. And we can only store one grade for Srinidhi. So, then we have.
There is only one Srinidhi index. Key can only be.
Yes.
So, there is another Srinidhi, then you have to
change, update it or do something else.
Do something else.
So, that is why it is useful to keep the index something which is guaranteed to be one per.
Unique, unique.
Yeah.
But I mean, sometimes, I mean, this way what you have done basically is you have taken the name or the card ID and you have given me the grade. Sometimes I want to do the opposite. That is, I want to do, here what you have said is for this card you have given a property which is grade. Grade is A or B or something. Sometimes I actually want to do the opposite. I want to find out how many people got an A. Or I want to find out, I mean, of course, that's a slightly like for words, right? The word thing. You want to find out how many words are of length 2. It's a very commonly very useful thing actually. How many words are of length 3? So I want to actually look at the distribution of word lengths.
So what we want to know is, given a length, how many words are there? Of that
I want to do
length.
opposite. Yeah. Normally the length count is there.
Yeah. So it's not a property of the card, but it's a property.
Kind of inverse.
Yeah. It's a kind of a
inverse relationship.
Some accumulated property. But you want to some statistics exactly. Some statistics.
Histogram, I think it's called.
Yeah. So you want to know how many words of length 1, 2, 3, 4.
Like that.
So what we can now do is we can keep that count, right? We can remember how many words are there. Initially we have not seen any words, so we have not seen any words
so
of
dictionary.
So we can have a dictionary. Yeah. So we have a dictionary, and we associate in that dictionary the count for every length. So the keys are the lengths. So length
keys
1
are the letter count what you got.
Letter count, and every time I see.
And the value is
how many words
are
I've seen with that letter count.
So initially the dictionary is empty, which means 0, I guess, presumably.
Yes.
You'll have to, when you find the thing, you'll have to put 1 there.
Yes.
So we try it. I mean, it might be interesting to try.
So we can do that. So
I want to find the histogram in this. I'm very keen.
So
I think there are some long words here, really long ones.
So this is a letter count.
I suspect that the number 3 will have the largest. What do you think?
3
or 2, 3.
I vote for 4.
You vote for 4. Okay, let's try it. Let's try it.
So initially this is an empty dictionary. Okay. So now we see the first word of length 2. So we say that
we enter a dictionary.
We create an entry 2
and put 1 against it.
And I'll put 1 against it because that's the count.
Okay. I'll put it this way so that it stays in order.
Yeah.
This is 3.
3. So this is also now the first word.
6.
6. So remember now in the dictionary we don't care in what order. We will find it by magic.
Now we are finding a 7.
7. 11.
We found 3 again.
So now we see 3.
So we update.
So we see that and we say, I'll just
count,
write. I'll just keep a count. So I'll just put another one. We'll do this counting. Okay.
9.
9.
2.
2. So I see another one.
4.
4.
Your man. 4. 3.
Okay. So one more 3.
4.
One more 4.
Okay. Going close. 2.
One more 2.
10.
That's new.
10 is new. 6. 6 is
6. One more.
9.
9. One more.
10.
10. One more.
2.
2. One more.
3.
3. One more. You're winning.
8.
8 is new, I think.
Yeah, 8 is new. 5.
5 is also new, surprisingly.
Oh, okay. 3.
3. One more. So now I've seen 5 of 3.
9.
9.
7.
7.
2. 8. 3. Okay, we're doing good. 6. 2. 3. 9. 2. 3. 4.
I'm doing very badly.
3. 6.
6.
4. Okay.
4.
2.
2.
4.
4.
3. 10. 2. 9. 2. 3. 4. 7. 2. 6. 3. 6. 6. 8. 3. 8. 11.
11. Okay, that's a new one.
Okay, this is new one. It's a long one.
Okay, so I'll put it on top here.
Yeah. 3.
Okay.
5.
5 is very.
7. Another 3. 10. 4. 3. Okay. 3 is doing really well. Oh, now you have 4.
4.
Another 4. Another 4. My.
Okay. So here we have this. Now we can kind of.
Oh, intuition is not
total-
so bad. Okay, I mean there are 3 and 4 are the last ones.
Okay, so 2 there are 9,
Yeah. Okay.
3 there are 15,
Huh.
6 there are 7,
Hmm.
7 is 4, 11 is 1. Oh, 11 was 1 there, sorry, I made a mistake. So this is actually, I created 2, this dictionary I cannot create, so there was already 11 there.
Hmm. So it's 2.
So it's 2.
Hmm.
4, 4 is 10, 4,
This is 5, huh? You cross it.
oh sorry, 5, 4 and then 2. So 2,
So if
3
you
and
go-
4 are the long ones.
So if you put it in order, I mean, of course, dictionaries doesn't have any order, but
Oh,
if
this
we
is not 9, this is 11.
if you try to put the if you put it in some order, what do we see? We
So-
see 2 is 11. So we can try and draw a histogram.
Yeah, we can try and draw a histogram. So we have
2.
so should we do it this way? 2, 3,
Yeah.
4, 5, 6, 7, 8, 9, 10,
11.
11. Right?
So 2 has 11.
Let me see.
Put a box.
I go to say roughly 5, 10, 15. Of course, nothing is 15. Okay, so 2 is 11, so that's somewhere here. 3 is 15, 16. 3 is 16 actually. And 3 is here. 4 is 10. 5 is way down here, it's 2.
Surprising, huh? Okay.
6 is 7. So it's a big difference. 7 is 4. 8 is also 4. 9 is 5. 10 is 4. And 11 is 2, like 5. So this is our
Draw graph.
yeah. So we can draw a line graph, or whatever it's called, of how this thing looks.
Yeah. All right. Some picture, huh? So, I would never have thought 5 is so low.
Yeah. So it tells you something. So I mean, this is expected, right? As the words become longer, in some
It will
sense,
go down.
the number
Generally
of
it will
words
go down.
should go down.
Should
But
go
why is 5 so unpopular? I don't know. I mean,
Yeah.
maybe they've all been stolen for Wordle.
Uh,
Some 5-letter words. Okay, so this
Okay,
is
so
something
this is
interesting
a-
now. So now what we have done is we have used a kind of a dictionary, not to record a direct property of the cards, but to indirectly compute something.
some statistics
Some
about the set of
statistics.
cards.
And here, unlike the other one where we always were only creating an entry in the dictionary once, like the seen card was seen only once. Here we are actually either creating the entry or we are updating the entry. The first time we see the card, we make an entry 1.
Yeah.
After that, we add 1 to whatever is the current count. So we are doing an update.
So many count. Actually, you're maintaining
Yeah. So we
it's a
are
collection of counters.
yeah. So each key is now. So we talked about this key associated with a value, but the value is not static now.
Ah.
The value is a number.
Key is also not static actually in this case because you don't know
Of course, keys are being added.
keys are being added.
Yeah, but that even here, as you see a new card, it will get
Okay,
added.
right, okay.
But the value associated with the key there was
It
fixed.
was fixed.
It will only be one grade, or it will only be one
correct. Yeah.
seen, unseen
Yeah.
business. Whereas here, the value is itself a number, and that number keeps growing.
Getting updated.
Yeah. So that's interesting. So we can now do that, right? So that's one more, and yeah, and we are doing. It's really this inversion, right? We have a. I mean, when we look at the card, we know the number of letters. We want to know for the
All
letter.
the number of letters.
Yeah.
What's the card?
So we could do the same thing, for example, with this grades, not the grade data set scores. We can ask how many students are from each city, for example.
Ah.
Right? So that also we could do.
Correct. We could do that. Yeah.
So
In this card deck, Chennai, I think. No, I don't know. We'll see.
let's see. So we want city count. Right. So the first city we see is Chennai.
Chennai. So you just put 1 again. Same
I'll
thing, huh?
put 1, yeah.
Same scoring.
Yeah.
Again
so now I
Chennai.
see Chennai again.
Bangalore,
Bangalore.
Madurai.
Oh, 1 second. This takes me longer to write.
Because the index is, yeah. Okay. Madurai,
Yeah.
Bangalore again.
Bangalore one more.
Vellore, Ambur, Bangalore again, wow, Chennai, Madurai,
Madurai one more.
Bangalore again,
Okay.
Chennai,
Yeah.
Salem, Nagarkoil, Chennai again, Trichy,
Okay.
another Trichy,
Okay.
Madurai,
Madurai.
wow, Madurai has a lot of students,
Trichy.
Vellore,
Okay.
Theni, Erode,
Okay.
Vellore again, Vellore is there already,
Yeah, Vellore is there again.
Erode again,
Yeah.
Madurai again,
Lot of Madurai is also.
Bangalore, surprising, Chennai, another Madurai, right?
Yep.
Another Chennai, another Chennai, okay, so we have done 30,
Yeah. So,
So,
we can.
Chennai has got 8,
So Chennai is 8, Bangalore is 5, Madurai is also 5, Vellore is 3, Ambur is 1, Salem is 1. This is Nagarkoil, which I didn't have time to write. This is Theni. So Nagarkoil is 1, Trichy is 3, 1 and 2. So
okay, yeah.
adds up to 30 also.
So, again same thing,
Yeah.
from a card we can say
Yeah, if the card tells us the city, we want for the city, how
City,
many
how many
cards, right?
so it's a
So-
kind of a statistics.
Yeah. So this is the key, and the value again is something that in this case, again like the other one, it's a counter.
Count.
So,
Okay.
so now here for instance, we had the number of students from each city, but what if we wanted to know which students they are? Right? We know there are 8 students from Chennai, but who are these 8 students? Or we know that there are 3 students
So,
from
go
Vellore.
back, I mean,
Then we'll have to go through the whole thing again. Every time we see Chennai, we'll have to pull out that thing. So we could have tried to, because if we know who are the students,
but here the value, I mean, question is, can you have more than one element there in the value?
so why not keep something more complicated than just one value? Like we know how to keep lists, right? So if we
Okay.
want to collect all the names of the students from a particular thing, we can keep a list of them normally. That's what we do.
So, in a dictionary we can put a list.
So why don't we just put a list there? Of course, then from the length, we will know how many are there.
I see. Dictionary allows you to put a list.
Why not?
Okay.
So you should think of a dictionary as you know, some kind of this locker. You know, you have a
Okay.
big cupboard, and in the key is the paint.
Key to, okay, open it.
Is,
to open
yeah, and the once you what you put inside is up to you.
it. Okay.
Right. So we could do that, right?
Okay. So, what do you want to do? You want to keep a list of all the cards, names, just cards, card numbers, IDs.
Card numbers should do,
Card
because
numbers.
then we can. I mean, it's just easier to write. So you say you want city by card. Right. So let me just write out these cities so we know them. Chennai, Bangalore.
Of course, each time as you go through it, the dictionary you will make that entry.
Yeah, so I'm just copying these just to save time, but initially we don't know these keys, that's true. So I'm right. So we should imagine that we don't know these keys.
Yeah. Okay. So, we go through it again.
Yeah. So now you
the
see Chennai, and now you see card number 2. So I
you
will
put
start a list here with 2.
Two,
in it.
two in it. Okay. Then I have another Chennai, 10,
Yeah. So then I will append 10 to that,
24,
which is Madurai.
Madurai, sorry.
So I'll start
Madurai.
24 a new list here.
17 Chennai, 9 Bangalore,
Okay.
4 Madurai,
Okay.
0 Erode,
So that's down here.
29 Vellore,
Okay.
18 Erode, 15 Theni,
Okay.
20 Vellore, 16 goes to Trichy,
Okay.
28 goes to Madurai, 14 goes to Trichy, 19 also goes to Trichy, 26 goes to Chennai, 22 goes to Nagarkoil, 1 goes to Salem, 25 goes to Chennai, 23 to Bangalore, 13 to Madurai, 3 to Chennai, 11 to Bangalore, 6 to Ambur, 7 to Vellore, 21 to Bangalore, 27 to Madurai, 8 to Bangalore, 5 to Chennai, 12 to Chennai.
At the end of this, now we have these lists. So we have a dictionary now in which the keys are the same city names.
So,
The
so you
va-
can, in principle, you can count.
Yeah,
guess
so
you
now I
just
can
count
say
on
1, 2, 3, 4, 5, 6, 7, 8, which is what we had here.
Oh, so
right?
you got more
Trichy-
information
Yeah,
here.
so Trichy we can say 1, 2, 3, and we had 3 here. So here we had only the count, here we have the actual
cards.
card. So we can go back and look them
Yeah,
up.
this
if
is
you
interesting because what we've done here is we have partitioned. Because every card has only one city.
Correct, correct. Every like 6 card 6 can appear only against Ambur. It can't appear in any other list because there is only one city on every card.
So you partition the cards by
City by city. Yeah.
And then if you want to do processing within one city, in
You can-
principle, you could do that.
Yeah, I could just
go
look
to
at
this
those
card
cards and those are all the Chennai cards and I can find out something about those Chennai cards. And for instance, if I wanted to find the average within Chennai, then I can just count
go down that.
or the maximum in Bangalore or something. I
In
can,
principle, I could keep that total or whatever it is as a pair here
yeah,
and then just process that,
correct.
right, and do whatever I want. I see. But in some cases, the lists may not necessarily be, here the lists are disjoint. They are not disjoint, some of the,
Yeah, for
Depends
example,
on-
it could be, let us look at the shops for example, right. So there are many shops and there are many customers.
the question is
And
what?
the-
Question is?
Supposing I want to know, I am a shopkeeper, I want to know who are all the customers who
Customers.
come to my shop.
Oh, I see. Same customer may go to another shop. Also.
Yeah, but I can't prevent that customer from, it might be different things also. I might be selling something when that somebody else might be selling clothes, I might be selling groceries. So the same customer may appear in different shops, but each shop will know who the customers are that come to them,
Okay.
right. So we could try that.
So,
So that's
here,
a different kind of,
so here the lists are overlapping. So
yeah,
if you add up, here in this case, if you add up all these list lengths,
yeah,
you will get the total number of cards.
yeah,
Whereas in this example, you will not.
correct.
No?
So here for
So what do you want to
instance,
do now? Which is the index now? Which is
so supposing I want to find out for each shop
okay.
who are the customers.
Opposite also. Okay. No. Yeah. That's what you would want to do.
Yeah, so the
Each shop who are the customers.
yeah, shop wants to know, right.
Shop wants to know. So your key is the shop.
Yeah, so
name.
I will write it this way, shop to customer.
Key is the shop name.
Yeah. Okay. So the first shop is Sun,
Abhinav.
Sun General.
Sun General is that.
So I
shop
create
name.
a list for Sun General.
And that has first element is Abhinav. I think you have to leave a lot of space. I think many.
Yeah. So I'll
Abhinav is the first customer.
yeah.
SV
Yeah,
stores
SV store. So I'll leave some space here.
has Advait as a customer. SV stores has Ahmed as a customer. SV stores has Abhinav as a customer. SV stores Srivatsan as a customer. You might get it more than once.
Yeah.
Huh?
So then you have to go and check if you have already added it or not.
Sun General has Srivatsan. Now first, Sun General we have introduced Srivatsan. If it is already there, we don't introduce again.
Yeah. So that's a little bit of extra work which you have to do.
Sun General has Advait as a customer. Srivatsan, Sun General. So it's just seen that I think.
Yeah.
So we don't add. Sun General has Aparna. SV stores has George.
Okay.
Sun General has Vignesh. SV stores has Neeraja. So far, no overlap, huh?
Well, Srivatsan is there in both, for example.
Oh, okay.
Advait is also there in both.
All right, Neeraja. SV stores has Vignesh.
Vignesh is also now there in both.
Okay. SV stores has Julia.
Okay.
SV stores has Akil. SV stores has Srivatsan.
That we have seen before.
Okay. Sun General has Suresh.
That's new.
SV stores has Akshaya.
That's new.
Sun General has Ahmed.
Sun General also has, okay, Ahmed we have seen in SV stores but not in Sun General.
Sun General has Rajesh.
Okay.
Big Bazaar Mohit.
Okay, so Big Bazaar is a new key. We have not
Oh,
seen
okay,
any
yeah,
Big
that's
Bazaar
right.
so far.
Mohit. You may not see Mohit also.
Yeah, both are new people.
Big Bazaar has Akshaya. Akshaya I think we saw.
Akshaya we just saw in SV stores.
Big Bazaar Radha. Big Bazaar Sudeep, Big Bazaar Advait. So there are some people who seem to go only to Big Bazaar. Big Bazaar Abhinav. Abhinav I think we saw.
Abhinav, Advait has gone to all of them.
Advait
Abhinav was in Sun General,
Okay.
and in CFC. Abhinav has also been to all.
SV Stores Akshaya.
SV Stores Akshaya, I think we already had.
Okay. SV Stores Neeraj also is there, I think.
Yeah, we already had.
SV Stores Ahmed.
Already there.
Another Ahmed. Okay.
Okay. So this now tells us
All right.
by shop who all.
So we can see which shop is getting the most number of customers.
Yeah,
for
that's
card.
one thing, for example. So SV Stores clearly has the largest number of customers in this. And we see somebody like, for example, Abhinav. Abhinav is in all three. Abhinav has here, here, and here. Similarly, Advait is here, here, and here. Advait, no, yeah, there. So
Vignesh,
Advait and Abhinav, I think, are the ones who have.
Vignesh is there only in these two.
Yeah. And Akshaya is not there. Akshaya. So there are 3 customers who go through all 3 shops. Some more who go to only 2 shops. Then
So
who
Mohit
goes to
goes
only
only to
one
Big
shop?
Bazaar.
For example, Julia, I think, is only here.
Julia goes only to SV Stores. Mohit goes only to Big Bazaar.
Radha and Mohit, I think, are specialists in Big Bazaar. And, so on.
Like that. Okay.
And we could do the reverse, right?
Yeah.
Of course, now since there are only 3 shops, for each customer it will be 1, 2 or 3 shops. So we will have, and of course there are many customers. So the number of keys will be more. But again, the idea that we can keep a collection, a list with each.
So basically, you can either you finding a property which is either a number, or now you have created a property which is actually a list.
Yeah, it's actually a
for the
list.
card.
Yeah.
You are storing it with the card. Not card actually.
Yeah, it's across. Yeah, it's kind of.
It's of the collection.
Yeah.
Okay. You are collecting some properties
Yeah.
of this card deck in some sense.
So you can think of the property here as being the name of the shop,
Name of the shop.
and for each name of the shop, you are collecting a list of all these names.
Okay.
Right? So this is very flexible kind of thing of. So every time you want to organize your information by some property, the property may be explicit in the card, it might be implicit like this kind of thing. And then against that property you can count, you can keep a list, you can do many things. So that's a good thing so to avoid recomputing the same thing again
and again. And this is a very, it's an attractive way to store these lists in the form of a dictionary. Either store the lists in the dictionary because there's a way to retrieve it, because you know how to retrieve it. So if you want to say something about, you want to find a property of Sun General, you just go search in the dictionary of Sun General and immediately retrieve this list.
Yes.
You don't have to go search.
So all the customers who have, what their customers look like and so on. So like in the last time also, if you want to know something about all the students who are from Bangalore or from Chennai, you can just go through those specific cards and look at those things.
Yeah.